Welcome students, this is your homework video for 224. The lesson is from Friday the 21st, Friday the 21st, and this homework assignment is going to be due on 224. It's on analyzing quadratic properties. So we first kind of introduced anything that has an x square in it has a graph that is in the shape of a U or in the shape of an upside down U. We looked at this point at the bottom and this point at the top being called the vertex. We also looked at something called the axis of symmetry, and that is what the same symmetry learned back in elementary and middle school. You can fold it across that. What else did we talk about? Domain and range. Domain, these things get forever wide. Okay, so even though they look like they go up and down, the width of them is wider at every place you go. And so the domain is always all real numbers, and the range is the one that's different. This would be greater than a number, this would be less than a number because it's going down. All right, let's get into the problems. All right, the first problem here, AOS stands for axis of symmetry. And our axis of symmetry is an x equals equation because an x equals equation is a vertical line, and we learned that back when we were studying lines. And so a vertical line that cuts this thing in half. So this line right here is going to be our axis of symmetry. When we have a graph, it's pretty easy to find it. So that axis of symmetry is x equals, you can see where it crosses right there, x equals 2. The vertex is found at that tippy top point right there. The axis of symmetry and the x of the vertex are always the same, 2. Then we have to figure out what is the y. Over 1, 2, up 1, 2, 3, 4, 5. So over 2, up 5. This point is 2, 5. That's the vertex. Minimum or maximum, that is the top of a hill, so that is a maximum height. X-intercepts are also known as roots, zeros, and solutions. Those words are all synonymous with each other. So the x-intercepts for this one are kind of tough to see. Right here, we could estimate that at about 0.5 and 3.5 right there. Sometimes they ask us to give the value which those are in between, and so this would be, this crosses between 0 and 1 right here, and this crosses between 3 and 4. So sometimes they ask us questions like that. Domain, I said, is all real numbers, and you can see it's only this thick right here, but when you come down here it's this thick, and then it gets this thick. So domain is all real numbers. So all real numbers. Every x value is going to be covered. This thing gets forever wide. The range, for range, we're going to figure out how low and how high does this thing go. This goes forever low, and it goes only to that point up there. So our range is associated where this connects up here at a y value of 5. Because this is pointing down, it's all things less than or equal to 5 is the range for this. So all real numbers, and then the range is y values less than 5. Because 5 is the highest, that's our maximum. Everything else is below that. All right, next problem. If we have an equation and we're trying to find the axis of symmetry, we taught you a little equation here, negative b over 2a. So we have ax squared plus bx plus c. So in this case, there's a 1 in front of that, so a is negative 1, b is negative 4, and c is negative 6. And for now, we don't really use c, but we will later on in the year. So we do the negative of negative 4, because that's our b, over 2 times negative 1. So the negative of negative 4 is positive 4, and 2 times negative 1 is negative 2, and 4 divided by negative 2 is negative 2. So our axis of symmetry is x equal negative 2. And if we wanted to find the vertex, we taught you in class that that's the x-coordinate of the vertex, and then our ways of finding the y are to plug that back into here. So you would do the negative of negative 2 squared minus 4 times negative 2 minus 6. And it doesn't ask you to do that, but I'm just reminding you of that here. So then you grab your calculator and you type it in exactly how I wrote it. Negative of negative 2 squared minus 4 times negative 2 close your parentheses minus 6 is also negative 2. So this has a vertex of negative 2, negative 2. Next one. So they give you these graphs here, or these equations, and you would really need to type these into your graphing calculator and get an idea of what they look like. What I'm going to do is do a sketch of each one of them up above here, and that way you'll have a good idea of what it looks like. Alright, so 3x squared minus 4, just based on knowledge that I know already that you guys don't know, this thing is going to be shifted down 4 units, and 3 is going to make it pretty thin, so it's going to look something like this. Okay. This one, negative 2/3 x squared plus 1. The plus 1 means we're going to shift that guy up 1. This negative out in front means it's going to go down, and that fraction means it's going to be pretty wide. It's going to be a lot wider than the other one. All right. And then the last one here, that 4 means it's been shifted up 4. Being a positive half means it's going to go up, and it's going to be wider because it's a fraction. And you'll learn all those rules later on. You're not supposed to know those yet. Alright, so then it says, A says, which of the functions have a maximum point? So which ones have a high point? Right, the only one that has a high point is graph 2. That is a high point. Which functions have the same axis of symmetry? So if I come in here with my red pen, that's the axis of symmetry of this one, this one, this one. So which ones have the same axis of symmetry? 1, 2, and 3 have the same axis of symmetry. Which functions have 2 x-intercepts? So which cross the x 2 times? 1, 2. So 1 does. 1, 2. 2 does, but this one doesn't cross at all. Which functions have no solutions? Which ones have the same vertex? And which ones have the same y-intercept? I'll let you guys work on trying to figure those out. This problem, it helps if you draw your axis of symmetry. So the axis of symmetry is this red line right here. And then what you do is we're concerned with when y is 3. So y is 3 right here. 1, 2, 3. Y is 3 right here. So this is 1 unit over this way. So if you go 1 unit over the other way, that is your point on the other side. Okay? And you can do that in other places. Here it's 3 units over, so if I go 3 the other way, then that gives me another point. And so that just allows me to do a little bit better sketch of what it's going to look like. Alright, and then we're supposed to figure out what goes with that 3. So if you look at the x's that go with 3, there's one of them, negative 2, and there's the other one, negative 4. Okay. Last one, we got a big word problem here. It says if a stone is dropped from any height, its distance can be modeled by the quadratic negative 16t squared plus h, where t is the number of seconds, so that's along here, and h is the height from the ground. The graph below models the distance from the ground of a stone dropped from the top of a tall building. From what height was the stone dropped? This models exactly what would happen. The stone was right there when it started, and so that's what it's asking. What is the height of that red dot? Okay? I'll let you figure that part out. You can do it. The stone was dropped when t equals, so the stone was dropped when t equals 0. Time hadn't started yet, and that's when the stone was about to be dropped. On the graph, t equals 0. At 0, what is that point right there? Right, so that's going to be the same answer as A. Circle the reasonable domain and range for this problem situation. We told you that domain is all real numbers for quadratics, but that's for just your standard algebraic quadratics like this. But once we get into a real world problem, you bring in this idea of reasonable domain. And so the reasonable domain is what x's show up on here. So we go $the robot left to right. So 0 to somewhere close to 3. So not that one because it doesn't go to 250. 0 to 2.6. Range, bottom of the graph to the top of the graph. So this graph starts at 0 and goes up to, I think it's actually 220. I think these are going by 25s, 75, 225. I think this top is actually 225. I think that's actually a typo on the sheet. 225. Okay. I think all of them. Make sure you finish up the ones, even the ones I did not do. You are responsible for them. See you in class on Tuesday.